Hi, welcome to the Olympiad geometry. Let's continue our study on Circumcenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Here is a problem. Circle O is a circumcircle of triangle ABC. O and triangle ABC. Circle K is a circumcircle of triangle AOC. Circle K intersects AB and BC on M and N. L is a symmetrical point of K to line MN. Prove that BL is perpendicular with AC. So just to have this problem set, it would be very difficult to figure out how to prove that BL is perpendicular with AC, right? So we definitely need some auxiliary lines. The question is that we have so many points in this figure. What are the auxiliary lines we're looking for? Just to think about BL is perpendicular with AC, right? We want to prove that BL is perpendicular with AC. How can we do that? Normally, if we want to prove two lines are perpendicular and we don't have any angle, the absolute number of the angles, so we want to find some other lines is perpendicular with the target line. For example, we want to find some other lines perpendicular with BL, and we want to prove that line is in parallel with AC, right? Or we want to find some other line is perpendicular with AC, and we want to prove that BL is in parallel with those lines that are perpendicular with AC, right? That's a part we can do the proof. So for this problem, can we find any lines that perpendicular with AC? Yes, it's very obvious, right? OK is perpendicular with AC. Because OA equals to OC, right? A, B, C are on the circle O. OA equals to OC. So O is on the perpendicular bisector of segment AC. And because K is a circumcenter of the triangle AOC, so AK equals to KC, which means K is also on the perpendicular bisector of segment AC, which means OK is a perpendicular bisect line of segment AC, right? So OK is perpendicular with AC, which means we just need to prove that BL is in parallel with OK, right? And if you look at this figure, you have the feeling that if we connect OB and if we connect LK, it looks like a parallelogram, right? So if we can prove that BOKL is a parallelogram, then it's obvious that BL is in parallel with OK, right? So BL is in parallel with OK. That would be the conclusion from BLKO is a parallelogram, which means that we have to find another way instead of using BL in parallel with OK to prove that BLKO is a parallelogram, right? So if we look at the figure, we have some line relations here that OB equals to OA equals to OC, right? If we want to prove that BLKO is a parallelogram, and we don't want to use a condition that BL is in parallel with OK, then we can do several other ways, right? For example, BO equals to LK and OK equals to BL, right? In that way, BLKO is a parallelogram, and we didn't use a condition that BL is in parallel with OK, right? Another side would be OB equals to KL and OB is in parallel with KL, which I would consider it's a little more difficult because when you want to prove in parallel, you have to find the angle relation. But if I can find the angle relation, why I don't just directly prove that BL is in parallel with OK? So based on these thoughts, I prefer to try to find the length relation between the segment OB, KL, BL, and OK. Why I want to find the segment length relation? Because we have two circles here. And look at these points, M, N, C, A, B. They are all on the circles. It gives us a lot of line relation, right? Because of the radius, all the radius are equal. So let's try to prove that OB equals to KL. The first thing I want to mention here, it would be, so if we just go to that proof, it would be maybe more difficult. Yeah, never mind. Let's just figure it out later. So the first thing is that LK is perpendicular. LK are the symmetrical point of line MN, which means LK is perpendicular with MN, right? It's not necessarily that these 3 points are concurrent. I just draw it bad, right? Don't think that this is a single point. Think it has 3 points here. Okay, so LK is perpendicular with MN, and because KM equals to KN, and L is the symmetrical point of K to MN, so we know that LM equals to Ln equals to Km equals to Kn, right? So Lm equals to, I may draw it bad, but you know what I'm saying. The Lm, because Km equals to Kn, so Lm must equals to Ln. Oh, okay, Lm equals to Ln equals to Km equals to Kn, right? For this part, that Ln equals to Kn, that's because L and K are symmetrical, right? And we also know that LK is perpendicular with MN. So we want to prove that BO is equal to LK, right? So LK appears in the triangle MKL, right? And we know that ML equals to MK. So LK in an isosceles triangle MKL. What about OB? OB equals to OA. And OA appears in an isosceles triangle OKA, where OK also equals to MK, right? So we actually want to prove that triangle MKL is congruent to triangle KOA, right? MKL and KOA, because we already know that ML equals to MK equals to KO equals to KA, right? So we just need to find or need to prove that angle LMK equals to angle OKA. Right. So angle LMK. Let's look at angle angle NMK, right? Angle NMK. That equals to half of angle LMK, right? This one is half of angle LMK. And it equals to 90 degree minus angle MKL. Right? The angle NMK, this one, equals to 90 degree minus angle MKL. And what is MKL? MKL is half of angle MKN, right? So that equals to 90 degree minus half of angle MKN. And half of angle MKN that's the thing we're looking for, right? If we want to prove that this angle, the angle LMK equals to angle AKO, right? Let me write it in this way. So, see, we have the angle LMK here, right? LMK. Let me write it in another way that will easier to consider about this issue now. So angle LMK actually equals to 180 degree minus twice of angle MKL equals to 180 degree minus angle MKN. Right? So the angle LMK, this one equals to 180 degree minus this one. That's a twice of angle LKM or MKL, which means twice of angle MKL, that is angle MKN. Right? And what about angle OKA? Angle OKA equals to twice of angle ACO. Right? Angle OKA, that's a twice of angle OCA or angle ACO. So let's just assume, let's just assume that if angle LMK equals to angle AKO, what we can get? That means this one equals to this one, right? Let me just write it on this side. That's our thought. If 180 degree minus angle MKN equals to angle twice of angle ACO, right? That means half of angle MKN plus angle ACO equals to 90 degree, right? And half of angle MKN. So in other way, let's just say that we want to prove that angle ACO equals to 90 degree minus half of angle MKN, which equals to angle MNK, right? Basically, we want to prove that this angle equals to this one. Okay, we want to prove this one equals to this one. And let's see another way. That's one way to explain this equation. And another way to explain this equation is that half of angle MKN equals to 90 degree minus angle ACO, right? Look at it here, because OK is perpendicular with AC, right? So and also, yeah, because KOOK is perpendicular with AC. So 90-degree minus angle ACO, that is this angle, right? This is half of angle AOC, which equals to angle ABC. So equals to angle ABC. In other words, we want to prove that angle ACO, this one, equals to angle MNK, this one equals to this one. Or we want to prove half of angle MKN, that means this one, equals to angle ABC, either way. Right, on this side is our thought, and for here is our real proof. So let's think about how can we associate angle ABC into this region. Let's connect AN. Okay. Now let's think about angle AKN. Angle AKN in the circle K, the angle AKN equals to twice of angle ACN. Right? Angle ACN is angle ACB. Right? Twice of angle ACB equals to angle AOB. Which means angle AKN equals to angle AOB. Which means, because AK equals to KN, so triangle AKN is an isosceles triangle. OA equals to OB, triangle AOB is also an isosceles triangle. And because we already know angle AKN equals to angle AOB, that means angle ADO equals to angle BAO equals to angle KAN equals to angle KNA. Right? Basically, I'm saying that triangle KAN and triangle OAB are similar. But most critical part is that this angle equals to this one. Right? So what we can get from here, look at angle ABN and angle, consider about angle ABC and angle BAN. Right, so here, the let me see. Yeah. So here, because second. Yeah, that's right. So because because the triangle BAO is similar triangle NAK, and we got this angle equals to this angle, so we know that angle MAN equals to angle OAK. Right? And equals to, see, angle MAN, this one, equals to angle OAK because of this angle equals to this angle. And angle OAK equals to angle AOK because KO equals to AK. Right? And angle AOK equals to half of angle AOC equals to angle ABC. Which means angle MAN equals to angle ABC or ABN. Which means AN equals to BN. Right? The most critical part is that the angle ABC can be represented for angle MAN. Right? So angle ABC equals to angle BAN. And do you remember what we are looking for? We want to prove that half of angle MKN equals to angle ABC, right? Half of angle MKN can be written as angle MAN. So we just prove it, right? Angle MAN equals to angle ABC, which, okay, based on this, that means half of angle, right? We just prove it. So angle MAN equals to angle ABC, right? Angle MAN, this one, equals to angle ABC. And this one, MAN, that's half of angle MKN, right? So half of angle MKN equals to angle MAN equals to angle ABC, which means we get these two. The angle LMK equals to angle OKA, right? Because all of these can be reversed, right? So let me just write it down here. Okay, think about, we already proved that this is valid. So half of angle MKN equals to angle ABC. Then because we already know that angle ABC can be rewritten as 90 degree minus angle ACO, right? Angle ABC can be rewritten as 90 degree minus angle ACO, right? Which means angle ACO equals to angle KMN, right? Or angle MNK. So this one equals to this one, right? We just prove this one equals to this one. And because this angle equals to this angle, so we know that angle AKO, yeah, because we already proved this one equals to this one. So actually, we just proved the angle MKL, this one, equals to this one, right? So angle AKO equals to angle KML. So we know that triangle AKO is congruent to triangle KML. Then we know that AO equals to KL equals to BO. Okay, now we proved that KL equals to BO. What about BL? We still want to prove that BL equals to OK, right? See, we already know that Ln equals to Kn, right? Ln equals to Kn. And we just prove that here An equals to Bn. And for this angle, the angle ANK, so we are looking at the triangle AKN and the triangle BLN, right? We're looking at these two triangles. Here we have several ways to prove. Let me try to use this way. So this angle, the angle MNB equals to angle MAC, right? The angle MNB equals to angle MAC, and angle MNL equals to angle NML. That is this angle, that is this angle, and equals to this one, equals to angle OCA, which means angle LNB equals to angle OAB, right? And angle OAB, we just proved equals to angle KAN, which equals to angle KNA. So we know that these two angles are equal, right? Let me write it down, maybe it's more clear. So angle MNB equals to angle MNL plus angle LNB. And angle MNL equals to angle DAC, right? So MNB, yeah, plus angle LNB equals to angle MNB equals to MAC, angle MAC equals to angle DAC plus angle DAB, which means angle LNB equals to angle DAB equals to angle no, not DAB, this is OAB, sorry. This is OAC. Yeah. Okay, this is OAC, no D here, just OAC, OAB. So angle LNB equals to angle OAB, right? OAB equals to angle KAN equals to angle KNA. Okay, now we have that LN equals to KN, we have BN equals to AN, we have this angle equals to this angle, which means KN, LN, no, BL, sorry, BL equals to AK, right? All of this just proves that triangle LNB is congruent to triangle ANK, right? Or KAN. So we know that BL equals to AK. And AK equals to KO. So BL equals to KO. And we just proved that KL equals to BO, which means OKLB is a parallelogram. Since it's a parallelogram, so BL is in parallel with OK. So BL is perpendicular with AC. So this is a problem from 26 Russia Olympiad. I think this problem is a difficult one. It's a very interesting one because we find a lot of interesting properties from this particular figure, right? We happenly, so let me just draw it here. We just find how to draw the how to find the perpendicular bisector of segment AB another way, right? Because we can first draw the circumcircle of triangle ABC, and then we find the circumcircle of triangle AOC. So when we connect the O and N, because AN equals to BN and OB equals to OA, we know that ON is actually the perpendicular bisector of segment AB. Similar, MO would be the perpendicular bisector of segment BC. And as you can see, this problem, you need to have a bold guess first that BLKO is a parallelogram, and then you can find you can try to use different way to prove it. I just feel for myself that in this particular problem, to prove it in angles would be more difficult. So I would prefer to use equal length to prove that BLKO is a parallelogram. But welcome if you have any easier, more elegant solution. Welcome to share it to me. I can show it to the audience. And I hope you like this problem. I hope you like this video. Thank you very much. See you in next one.